Welcome to question 6 of the year 9 acids end of unit test, and question 6 is the big one, isn't it? 15 out of 49 marks, almost a third on the back page. Acids and alkalis react by forming ions. What is an ion? Well, it's just a definition you've got to learn, I'm afraid. An ion is an atom or a molecule that has lost or gained electrons. Here is the word equation for a chemical reaction. Sodium hydroxide plus sulfuric acid gives sodium sulfate plus water. And there's a mighty 4 marks to get here. Really, really easy marks to get. And what's it going to tell us? Well, it tells us that when sodium hydroxide is added to sulfuric acid, there is a reaction that makes sodium sulfate and water. Okay, it's as simple as that. When sodium hydroxide is added to sulfuric acid, there is a reaction that makes sodium sulfate and water. That's all there is for 4 marks. Complete the following word equation. Hydrochloric acid plus sodium hydroxide gives something and something. Well, look, we've got an acid and we've got a hydroxide. So it's an acid plus an alkali reaction. And we know that an acid plus an alkali reaction is a neutralization reaction, which gives a salt and water. Okay, so we can write water in as one of the answers because it's a word equation, right? It's got to be words. If you put chemical symbols in there, you're not going to get the marks because you're asked for words, a word equation. Now we've got to decide is the name of the salt. Well, we know that hydrochloric acid, HCl, makes chloride ions. And we know that sodium hydroxide, well, sodium is NaOH. We know that the hydroxide bit reacts with the H bit to make the water, which means the sodium reacts with the chloride bit to make sodium chloride. So not that you had to put the chemical equation, HCl plus NaOH has gone to make NaCl plus H2O. The OH and the H react to make H2O, and the Cl and the Na react together to make NaCl. Okay, balance the following formula equations for the acid-alkali reactions. So it gives you the equation, and here's one I've prepared earlier, and it's going to ask you to balance it. So what we're going to do, on a piece of scrap paper somewhere, we're going to write our tally chart, and our tally chart is left and right and ions, and then we're going to do some counting. Okay, we're going to look to see what we've got on the left. Well, we've got hydrogens, H2. Right, have I got any other hydrogens? Well, look, here's an OH group. That's an hydroxide ion. Now, we're going to check to see if it's on the other side as well. Because if it's on the other side as well, we can count it as one big lump. But on the other side, NaSO4, H2O. No, the OH group has been split up. So it's here, but it's not here anymore. So I need to count the hydrogens, this hydrogen in with this hydrogen. I've got 2 hydrogens here, H2, and I've got 1 hydrogen there. So H, on the left-hand side, I've got 1, 2, 3. SO4, well, that's a sulfate ion. Right, now I'd like to count that as one big lump because it's a great big ugly thing. A sulfur and 4 oxygens joined together. Is it on the left and on the right? Well, here it is, SO4. Is it on the right? Yes, it is. Look, it's over here as well. So I'm going to count that just as one lump. I'm going to call that SO4. It doesn't get split up, you see. It's the same here as over here, so it doesn't get split up. So I'm just going to count it as one big lump. Next one along, sodium, Na. Well, it's there and it's also over there. So, oh, didn't do the counting, did I? Idiot. SO4, how many SO4s have I got over here? Well, I've just got 1 SO4. Sodium, back to sodium. Sodium on the left hand side of the arrow, I've got 1 sodium. I've counted this hydrogen, so that just leaves this oxygen, and I've got 1 oxygen. Right, so that's my count for the left-hand side of the equation. 3, 1, 1, 1. Now I'm going to go over to the right-hand side of the equation, the right-hand side of the arrow. Here's the arrow. How many sodiums I've got here? Na2. Na2 means 2 sodiums. SO4s. How many SO4s have I got? I've got 1. Plus H2. How many hydrogens there? Well, that's 2, isn't it? And how many oxygens in H2O? It's just 1. So now, there we are. There's my unbalanced equation. I've done my counting. Now I'm going to look at the balance. H. On the left, I've got 3. On the right, I've got 2. A hydrogen has disappeared. I can't have that. SO4s, I've got 1 on the left and 1 on the right. That's fine. We're good for that. Sodiums, I've got 1 on the left and 2 on the right. Right? Well, I've got a sodium appearing out of nowhere on the right-hand side. That's no good. Can't have that. Oxygens, I've got 1 on the left and 1 on the right, so I'm good for that. So what am I going to do? Well, I'm going to look at hydrogens first of all, and I'm going to say, well, I can't have a hydrogen disappearing. I've got to add more hydrogen in somehow, and the only way I can add them in is by adding the big ratio numbers. I can't change the formula of H2O. I can't make it H3O because that doesn't exist. That's not what water is. H2O is H2O. It's 1 oxygen and 2 hydrogen atoms. The only way I can add more hydrogen is to put a big 2 here, a ratio number. And as soon as I put a ratio number, I'm going to do a recount on everything on the side of the equation where I put the ratio number. So on the right hand side, I'm going to do a recount. So how many sodiums have I got? Well, I've still got 2. How many SO4s have I got? I've still got 1. How many hydrogens have I got? I've got 2 times H2. 2 times 2, I've got 4 now. Okay, how many oxygens have I got? I've got 2. 2 times O, 2 times 1 O is 2. Right, has that made things better? Well, my hydrogen's still not balanced. Oh dear. My sulfate's balanced. My sodium situation, that's not balanced now. Right, that's not balanced. I've got 2 sodiums on the right and only 1 on the left. And oh dear, I've made it worse here for oxygen. I've now got 1 oxygen on the left and 2 on the right, so I've got a balance there. What am I going to do? Well, let's look at the situation. Somehow I need to get an extra hydrogen, an extra sodium and an extra oxygen on the left-hand side of the equation. How am I going to do that? Well, I can't change the formula of anything over here. I can't change the formula of sodium hydroxide. It's NaOH. I need to be able to add 1 hydrogen, 1 oxygen and 1 sodium. Well, if I did this, what would happen then? Well, let's see. I've put a ratio number in, so the first thing I'm going to do is do a recount. How many hydrogens have I got altogether now? Well, I've got 2 here, H2, and I've got 2 times H2 there. So 2 plus 2 is 4. SO4s, I've still got 1. That's good. How many sodiums have I got? Well, I've got 2 times Na1. I don't want the 1 in yet. 2 times 1 is 2. How many oxygens have I got? I've got 2 times 1 is 2. Now let's look at the balance. Hydrogens, 4 and 4, I'm balanced. Sulfates, 1 and 1, I'm balanced. Sodium, 2 and 2, I'm balanced. Oxygen, 2 and 2, I'm balanced. So the balanced formula equation is H2SO4 plus 2 NaOH makes Na2SO4 and 2 H2O. Moving on to the next one. HCl plus CaOH2 gives CaCl2 plus H2O. Now I can't change the formula of any of those things. That's hydrochloric acid, that's calcium hydroxide, that's calcium chloride, and that's water. So I'm going to do my tally chart. Left, right, and ions. Okay, and I'm going to count everything on the left hand side. So I'm going to start with, I've got a hydrogen there, and I've got some hydrogen in here and a hydroxide ion. I need to check that that hydroxide ion isn't there and on the right hand side, because if it is on the right hand side I could just count it as a hydroxide ion. Let's have a look. Is it over here? Can I see an OH? No. Okay, so I'm going to have to split this OH up into separate atoms. So I've got one hydrogen there and I've got a hydrogen in there, but look, it's in brackets, so it's 2 times 1. In total I've got 3 hydrogens on the left hand side. Chloride ions. Let's look. I've got Cl, I've got 1 there. Calcium. How many calciums? I've got 1 on the left hand side. And now I'm going to look for oxygens. Well, it's an OH, so there's 1 inside the bracket, but I've got 2 of everything inside the bracket, so it's 2 times 1. I've got 2 oxygens. Now I'm going to go to the right hand side and I'm going to look. How many hydrogens have I got? Well, it's here, H2. I've got 2 hydrogens. How many chlorides have I got? Cl2, I've got 2. How many calciums have I got? I've got 1. How many oxygens have I got in H2O? It's just 1. So now let's look at the balance. Hydrogens, 3 is turning into 2. That's not balanced, that's no good. Chloride, 1 is turning into 2. That's not balanced, that's no good. Calcium, 1 and 1, we're happy with that. Oxygens, 2 turns into 1. We're not happy with that. So the first thing I'm going to do is address the hydrogen situation. I need more hydrogens on the right hand side. I can't change the formula of H2O. I can't make it H3O or H4O because water is H2O and it always will be H2O. The only thing I can do is make more water, make more of it by adding a ratio number. And as soon as I add a ratio number, I immediately do a recount. How many hydrogens have I got now? 2 times H2, 2 times 2 is 4. How many chlorides have I still got? I've still got 2. How many calciums? I've still got 1. How many oxygens? 2 times H2O, it's 2 times 1, it's 2. Now let's look at the balance again. 3, 4, not balanced. 1, 2, not balanced. Calcium, balanced. Oxygen now seems to be balanced. Happy days. 2 and 2. So let's look at the situation. I'm short a hydrogen on the left hand side and I'm short a chloride on the left hand side. How can I add one H and one Cl on the left hand side? Can't change the formula of anything. All I can do is add the large factor number. I'm going to add it there and I'm going to immediately do a recount. How many hydrogens have I now got? 2 times H, 2 times 1 is 2, plus the 2 times 1 in there makes 4. 2 times 1, chlorides, 2. Calcium, still 1. Oxygen, still 2. Let's look at the balance again. 4 and 4, happy. Chloride, 2 and 2, happy. Calcium, 1 and 1, happy. Oxygen, 2 and 2, happy. Our equation is balanced.